So the first algorithm that we talk about is called logistic regression. Okay? So logistic regression is very much like regression, just that we are converting the concept into classification problem. Okay? So let me share my screen. Okay. So first we'll import NumPy. Okay. And we will import pandas.
Yeah.
We will read the data set. Okay.
Yeah.
So of course here you have to read different data set, right?
Yes, sir.
CSV. Okay.
Yes, sir.
My voice is breaking.
Now okay.
Okay.
Yes, sir.
This. Go to machine learning. Here I have add success.
Okay.
Now see here. So what we're looking at, okay, can you read the columns that are there?
Yes, sir. User ID, gender, age, estimated salary, purchased.
Right?
Yes, sir.
And what do you think from this? Do you
5 adds success in the sense maybe purchased will be Y part, sir. Output part. And first 4 columns are input, X part. And in this also, if we consider gender is user ID, maybe just an identification, so it has nothing to do with the outcome. Considering these 3 also, gender also maybe nothing, and categorical variabilities. So we can consider this age part and estimated salary part for predicting. Maybe they're purchasing some item or maybe. So yes or no sort of thing. Purchased, if we observe, we have 2 values, 0 and 1. Maybe 0 is false and 1 is for true, generally as we consider. So they might have gone for purchasing a product or not opting for it, like that. Those 2 are the outcomes. It's like binary classification sort of thing.
yes. Okay.
Yes,
so
sir.
as you said, user ID will not have any role to play.
Yeah.
So gender, age, and estimated salary.
Yes, sir.
Okay. So gender, age, and estimated salary. These are the factors based on which we'll decide whether a person will buy or not.
Yeah.
Okay.
Yes, sir.
So for us, this is our why, right? And it is a binary classification. It's a classification problem because we have to predict yes or no.
Yes,
or
yes.
one.
Yes, sir.
Okay. And then, of course, these 3 factors. Okay. So let's go to our program. Okay, I'm going to get that raw link.
Yeah.
Okay.
Yes, sir.
So we got the raw link. Now we need to divide into X and Y, right?
Yes.
So the pre-processing steps, right? Everything is exactly same as what you would do in a
regression.
So X equal to data set dot ILOC, okay, and
all the rows,
but we don't want
first one, user ID. We don't want
user ID.
Yeah.
Right?
Yes,
So
sir.
you have to say 1 colon 1, 2, and
3.
3.
Yeah.
Right?
So we need to go for 4.
Right?
Yes, sir.
Okay. So I think for this you don't have to give bracket. Okay. If you're giving
Yes, sir.
specific
Yeah.
columns,
Yeah. We
then
need to
we
give
give
in
the
brackets. Yes.
Okay.
Yes. Dot values.
Dot values. Now same thing we have to do for y.
Okay.
Okay. So y all rows, right? And we want only
Last column.
4th column.
Yes.
Is it 4th or 3rd? User ID and 3. Oh, okay. Yeah, 5th one is that other thing, right? Okay, great. So we have our x and y. Now we need to perform the pre-processing. So we have to do standard scalar because age and salary, they are in different what do you call? They are in different numbers. Age is 2 digits and salary is 4, 5, 6 digits.
Yes, different range. Yes, sir.
Different
Yes.
range. So we have to perform
Yeah.
a scalar. Okay.
Yes,
But
sir.
before that, we also need to handle this categorical value.
Yeah.
Right? So
Yes,
how
sir.
do we handle categorical value?
Column transformer, one hot encoder.
One hot
And,
encoder, isn't it?
Yes, sir.
So we have to perform one hot encoder
Yes.
to get that
Male female column just
male female
coding.
column.
Yes. Yes, sir.
Correct. So so we need to import. Do we need to import anything?
Yes, sir.
What all things we need to import?
SQL learn dot pre-processing.
Okay.
One hot encoder, label encoder. One hot encoder. And
right.
from
So I'm going to say from SQL learn
pre-processing.
Pre-processing.
Import.
Okay. Import.
Label encoder.
Label encoder.
And this one hot encoder. Yes, sir.
Right. Then
and this also, sir, column transform.
Column transform. Right.
sklearn dot compose.
sklearn dot compose import
Column transform.
Column transform. Right.
Yeah.
So now we have to start doing our work. So let's create a label.
Yeah.
As label encoder.
Okay.
Okay.
Yes,
now X is what? X all rows and
only first column, sir. One. Sorry, column having one.
No, but we have already made it one column, right? So X 0 column, right? We are reading from
yes.
data set.
Yes,
from data
yes.
set.
Understood, sir.
We have already dropped.
Yeah. Yeah, user ID is already dropped. So
Drop.
now, yes.
So
I
equal
got it.
to label dot fit transform.
Yes.
Right? Label dot fit transform.
Yes, sir.
And here we have to say X 0, right?
Yes, sir.
So this column transform is done.
Sir, one second, sir.
Yes.
I have a doubt regarding this. Sometimes we are doing fit transform and sometimes we are doing only transform.
So fit is to the training.
Okay.
And
transform in the sense. Okay.
To get the value in the get the final value, isn't it?
Okay. But we are not training it.
No. So fit is training. Okay.
Yeah.
Transform is putting the different. So you can combine or do both the steps together, or you can do it differently.
Okay. Yes, sir.
Okay. So then transform equal to your column transformer, and we need to pass a list of tuples. So what we pass here first?
Hot encoder.
One hot encoder. ONE underscore hot underscore encoder, isn't it?
Yes, sir.
And then
the one hot encoder.
one hot encoder.
Column 0.
Right?
Yes, sir.
And then enter password.
Yes, sir.
Okay.
Yes.
So let's run so far. See if you get any error.
No, sir. We are not printing anything. Yes.
Perfect. Yes. Okay. Now
Yes.
we will what I was thinking is
Yes, sir.
let's transform, okay, the entire X. Okay.
Okay.
So X equal to, okay, we'll add the other values to it, right? So
Okay.
X equal to np dot array. Okay.
Yeah.
Then we say transform dot fit transform X. Correct?
Yes, sir.
And we'll say D type. Okay, we'll take np dot float.
Float. Okay.
Okay, and now we'll say X equal to X. Okay, all rows and from one. We're dropping one gender.
Yeah.
Print X. Now let's see if we get the value of our choice. Right, we got it, right? Value of our choice. Now
Yes.
we need to perform scalar, standard scalar.
Yes, sir.
So what do we need to import? From pre-processing, we have to import.
Yes.
sklearn dot pre-processing import
Standard
standard
scalar.
scalar. Okay.
Yes, sir.
And then I'm going to say standard scalar equal to standard scalar. Object is ready. Now we have to transform. Now I can transform entire thing, isn't it? I don't have to. So I can say X equal to, okay, X equal to your standard scalar dot fit transform.
Yes, sir.
Okay, and here we'll say X. Right?
Yes, sir.
So done. Now we have to break it into test, train and test split, right?
Yes, sir.
So from sklearn dot
Model selection.
import
Train test split.
and test split, right?
Yes.
And this is going to give us 4 values. First X, then Y. So X train, comma X test, comma Y train, comma Y test. Okay,
Yes, sir.
equal to train test split. Okay,
Yes, sir.
we have X, comma Y. Okay,
Test
and
size.
test size. Okay, 0.25. Let's see.
Yeah. Random state.
Random state. If you want to give, you can give. So our train test split is ready.
Yeah.
Now we have to call the classifier. Okay.
Yes, sir.
So this is your pre-processing step, right?
Yes, sir.
Now we need to call classifier.
Yeah, this is actual processing.
Right. And then we have to do the confusion metric, right?
Yes, sir.
So first thing they said, let's talk about, okay, we'll talk about linear regression or logistic regression actually. Okay. So in logistic regression, we perform regression, okay, and then we give a support value. We say something, after this point, it is your, like we put 50%, right? So if, see, when you say 0 and 1 is the value, right?
Yes,
And
sir.
regression will predict as 0, 0.1, 0.2, and up maximum up to 1. So anything below 0.5 will be treated as 0, and above and equal to 0.5 will be treated as 1.
Okay.
Okay.
Yes, sir.
So let's call this model. So this is also in sklearn linear model. So from
Okay.
sklearn dot linear model import logistics regression.
Okay.
Okay.
Yes, sir.
Now you say classifier equal to logistic regression.
Okay.
Okay. That's it. Okay.
Yes,
Now
sir.
you have to train the classifier.
Yeah.
Okay. Classifier dot fit. Train on what? X
X
train and
and
Y train.
Y train. Yes.
Okay.
Yes, sir.
And then you simply predict the value.
Yeah.
So Y pred equal to classifier dot
predict
predict
of Y
and
test.
X test. Right. You predict X
Ah,
test.
yes, sir. Sorry. X
You'll
test. Yes, sir.
compare, yes, and you'll compare on Y value.
Yeah.
Right. So this is your classifier.
Yes, sir.
Now we have to perform post processing
Okay.
or model evaluation.
Yes, sir.
Model evaluation, we need to build confusion metric.
Okay.
Okay. Now in confusion metric, we have to call from, you have something called as sklearn metric, isn't it?
Yes, sir.
So from sklearn dot
Matrix.
metrics import, okay, classification report.
Okay.
Okay.
Yes, sir.
Classification report, accuracy score. Okay. And also your confusion metrics.
Okay.
3 things we'll do.
Okay, sir.
Okay.
These all
So
come
your,
under post processing.
yes. So CM equal to confusion metrics. So confusion metrics of what we need to build? Okay.
Y test and Y
Yes.
predict.
This is your, okay. So this is your, see, we discussed about training set and test set, right?
Yes,
So
sir.
what we are doing is for the test accuracy, you have to find train accuracy as well. And then you have to compare. Okay.
Yeah,
So,
yeah.
so I'll say CM test and I will say CM train also.
Okay.
So create both. Okay. So here it's going to be
Y train.
Y train. Okay. No, this is not going to be Y train. Okay. So Y train, but you have to predict, right? Y train predict. This is the actual, but use same model to predict the Y train also. So I'm going to say Y pred, okay, Y train pred, okay, and predict on X test. Okay, so X test is done X train. So we are training and then we are testing on the same paper. Whatever question paper I gave, same question I'm asking to see how well you have done the training preparation or how well you have done the preparation.
Okay.
Right. So,
Yes,
so this will give us, this is the actual value and this is the predicted value for Y train, X train, I mean, Y train predicted. So now you compare the accuracy score of both and see how is your accuracy score.
Okay.
Okay. So accuracy score and you can classification score can calculate same way. I'm going to do only accuracy score. Okay. Accuracy score. Okay. So let's say accuracy test. Okay. Accuracy train. Okay. In accuracy score, we need to pass your original value, which is y train, and your predicted value, y train
Train.
predicted.
Yeah.
Okay, here is going to be your y test
Vibrate.
and y
Vibrate.
pred. Okay,
Yes.
now let's run and see what happens. We have not printed anything.
Yes, sir.
Print, say confusion matrix. Okay.
Yes, sir.
First, we will print training or test, let's say. Test. Okay.
Yes.
Now we predict for training. Okay. Yeah. Similarly, you can predict the accuracy score. Okay. So you see this accuracy of training is 0.84. Definitely is going to be more, but accuracy is almost in same range.
Yes, sir.
Okay. That means, a model is doing a relatively good job.
Okay. Yes, sir.
Okay.
Yeah,
So
yeah.
this is how we run our classification problem.
Okay.
I have updated the last this thing, right?
I think it's polynomial regression, sir.
No, because last week we did theory, right?
Yeah.
So,
After this, we have done these all sir, random forest, decision tree. Just
right.
a small part of code is changed. That's it.
Correct.
Yes.
So
After that, only theory.
here I have. Okay, let's do visualization. You there?
I got the notes also, sir. I have checked it.
Right. Okay.
Yes.
So let's visualize, or
Yes,
you will
sir.
do the visualization by yourself.
As you say, sir.
Yes. Do the visualization.
Okay.
Okay. And show me tomorrow. Okay. If you have any question.
Okay, sir. So just tell me what all should I do, sir?
That's all visualization. So when you go to the regression,
Okay.
on I think second, third, or fourth page, you will see the steps.
Okay.
Okay, all the steps. So you
Okay.
perform that.
Yes, sir. Sure. I'll do it today.
Okay.
Yes, sir.
Yes. And then tomorrow we'll talk about few other classification problems.
Models. Yes, sir. Okay.
And hopefully by tomorrow we'll finish off the basic models, and day after we will finish off the other couple of models that we have
in classification.
Classification, yes. Then we can go to the
clustering. Yeah. Okay.